Good morning, everybody. I wanted to start this lesson off with a quick little warm-up on finding the area of the given shapes. I think this is going to just help us a little bit as we go into our next lesson, which is going to be finding the volume of shapes. All right, so let's go ahead and start off with number one, right? I want to find the area of the shape, right? So just a quick little review of what area means, right? Area is just going to be the number of square units that cover this entire shaded region enclosed by the rectangle. All right, so there is a formula for this. The formula for this is going to be equal to you can say length times width, or we can say base times height. So it just kind of depends on how you've seen it. I see a lot of people say base times height. So notice how these are lowercase. This is going to be important because when we get into our lesson, there's going to be an uppercase B and an uppercase H, and they're going to mean slightly different things. So we can think about this as base times height, and typically the value that is maybe touching the floor per se is the base, and then the other guy, the perpendicular distance, is going to be the height. So this is a rectangle, so we know it's a right angle, we know it's perpendicular, so all we got to do is just multiply these together. So the area for these two is going to be the base, 10.5 meters, times the height, 3 meters. So I'm just going to plug that into my calculator. So 10.5 times 3, and that's going to give me 31.5 meters squared. Right? The reason why it's squared is because that's how we count up the area, right? It's little square boxes, right? That's why we put meters squared. We're trying to count up how many little tiles can we fit. We can fit 31.5. All right, let's go to the next one. For our circle here, to find the area of a circle, remember that the formula is going to be equal to pi times r times squared. So I'm just gonna, the way I like to do it, if we were in class, it'd be a little bit different, but since you guys are online, I want to just make this a little bit easier for you. We're just gonna make pi 3.14. And then we're just gonna take the radius and we're just gonna plug it into the formula and square it. And I'm just gonna plug this whole thing into my calculator. So 3.14 times 4.5 squared, and the area of this circle ends up being 63. I'm just going to write the whole thing out. It's not that long. 0.585 meters squared. Okay. And then our area of a triangle we have down here. Remember, area of a triangle is 1/2 times the base of the shape times the height of the shape. So remember that the base and the height have to be perpendicular from each other, right? So this has to be a right angle. It's not labeled as a right angle, but I'm going to go ahead and throw it in there. So we know that this is going to be the base here, and then this is going to be the height. So let's go ahead and just plug it into our formula. We have area equals 1/2 times my base of 6 times my height of 7. I'm going to go ahead and multiply those all together. This is going to become 3. 3 times 7, that's just 21 meters squared. All right, so let's go ahead and get into our lesson now. All right, so our lesson for this week is going to be to find the volume of three-dimensional shapes. We're going to focus on certain shapes that are called prisms, spheres, pyramids, cylinders, and cones. So as we go through this lesson, you'll be able to learn a little bit about what these shapes are and a quick formula on how to find the volume. Let's go ahead and get started. All right, so the first thing I wanted to do was find the volume of a prism. So first we need to understand what a prism is. You might have seen this word in other contexts, but in math, a prism is a three-dimensional shape that is basically created by stacking a two-dimensional base shape on top of itself many times. So for instance, what that is basically trying to say is, let's say we have a shape like, let's say we have maybe like a square, right? Let's take a square. Let me try to draw like a three-dimensional square, right? So here's a square, right? It's laying flat on the ground, right? Now what I'm going to do is I'm going to go and let's also say that this square has some width, right? Some really small width. And then I'm going to go ahead and I'm going to stack another one right on top. Right? I'm going to stack another one right on top. And I'm going to stack another one on top of that. So I want you to imagine what would happen, what kind of shape would you get as you continuously stacked a bunch of squares right on top of each other, right? So I'm hoping you would end up getting something like a cube, right? As we stack all of these, squares on top of each other, they would get some sort of height, right? They would just increase in height, and we'd end up with something like a cube, right? So that's the basic idea there. But typically that's basically how you would think how a prism would be created. But typically the way we identify a prism is the base shapes are always going to be parallel and face each other in prisms, right? So let's look at some examples of these prisms and let's see it. So let's identify the base shape here. So for this, I'm looking at this shape right here. I want to identify what is the base shape of that guy, right? So the base shape of this guy, we'll find where do they have the same shape that are parallel and facing each other. Well, we can see that right down here, right, this is going to be this is going to be the base shape right here. How do I know that's a base shape? Because exactly opposite of this, right, is going to be the exact same shape. It's going to be the exact same shape. Now, there's another part of this definition that's not I'm not including it, but with the prism, you have a base shape, and then everything else creates rectangles, right? So everything else would create a rectangle. So like here we have a rectangle, right? Here's a rectangle. Here we have a rectangle. So all around it gives you rectangles. So that's the other part of the definition. So that's why that, what is that at 1, 2, 3, 4, 5, that hexagon has to be the base shape because everything else leaves you with rectangles. All right, let's look at this one right here. What do you think the base shape of this guy is going to be? You actually have a few options here, right? Because this is called a rectangular prism. Oh, by the way, I know we should probably name this. This is called a hexagonal prism, right? Because the base shape is a hexagon. All right. This case, your base shape is going to be a rectangle. Now, you can choose a lot of base shapes, right? Let's say I pick this one, right? I can pick this as my base shape. This could be it right here. How do I know that? Because the opposite side has the exact same shape, right? And they're facing each other. So if I get a different color here, I know that they're facing each other, right? They're exactly parallel and facing each other here. But you can also pick another base shape. There's actually like a few you can pick here, right? We can also pick, this side as being the same shape, as being the base shape, I'm sorry, right? I can pick this as being the base shape because I know opposite it is the exact same shape and everything else is made up of rectangles. And then lastly, we have just like the top, right? Like the roof of this shape could also be a base shape, right? Because if I were to color this in, I know I would have the exact same thing at the bottom. Okay, I know it's getting kind of messy with all the colors, but hopefully you guys follow along. So it's really up to you on which one you pick in that case. But either way, this is known as a rectangular prism. And then down here we have can you guess what this is called? This is called a triangular prism. Right, and we can see that we have a triangle as the base shape, right? Here's my triangle, and straight across we know we have the exact same shape, and everything else is made up of rectangles. Right? We can see that this whole sheet here is made up of a rectangle, right? We can also see that this panel is made up of a rectangle, and then the piece that's on the floor, right, is made up of a rectangle as well. Okay, so now that we kind of have an idea of what a prism is, let's look at the formula for how to calculate the volume. Okay, actually, there's one more type of shape that I want to go over, which is called a cylinder. Now, a cylinder is very similar to a prism. They just give this a specific name because the base shape is a circle. So whenever your base shape is a circle, although I would consider it a prism, it's technically called a cylinder. All right, so let's go ahead and look at the formulas for these shapes. Okay, so the volume of a prism has a specific formula that, although it looks like it's made up of just two components, it's made up of a little bit more. So if you notice, the volume of this says it's B times the H. So what the B actually means, right, this B, it actually means the area of the base shape. So if I were to look at this prism over here, we kind of looked at this one earlier, right? If I look at the area of this base shape, this would be the base shape. So whenever it says to find, whenever it says find the area of the base shape, I have to actually find the area of that shape. That's your B. So that B is kind of made up of a few things, right? That B is made up of a base, right? A little b, right? This is your little b right here. Okay, this is your little b, whereas inside of here was your big B. So big difference, right? Big difference on what we're looking at. And then we also have our h, right? Our height. So that's going to be your height right there. So let me go ahead and write our height there, and this is going to be the height, right? Little h. But then we also have our capital H. So capital H is going to be the distance between the base shapes, right? So find your other base shape, right? My other base shape is going to be all the way over here. Whoops, I wanted a highlighter. It's going to be all the way over here. So what would the distance be from one base shape to the other shape? So we've got to, we have to find that distance. So this is going to be the distance, right? This is known as your H, right? This is your capital H. It is the distance between those two shapes. So basically what we're doing is we're finding the base shape, and we're basically multiplying it by how many of those shapes you've stacked, right? I've stacked 17 feet of shapes. So basically take that area and multiply it by 17. So that's kind of the idea there. Let's go ahead and look at an example of calculating the volume of a prism.